In 6.4, we're going to end this chapter with dilations. And dilations are specifically in this spot because a dilation, the objects that are dilated are still similar. And the word similar means proportional. So we do all these sections that deal with proportions with triangles, and then we move into dilations, which can be used for anything that make things still in the same proportions. And you see these all the time. Your generation, I say that a lot. I've been saying that way too much lately. But because you guys are the cell phone generation, you guys know how to enlarge or reduce something. You put two fingers on it and you enlarge it, or you pinch it and it makes it smaller. You're used to that. There are times where it's touchscreen and you know exactly how to use it. That's what these are. Dilations are when you enlarge or you reduce. That's what we're doing right now with this touch laptop. Okay? So what you're going to have to decide today is you're going to have to decide, was it an enlargement? Did it get bigger or did it get smaller? And the hardest part about that is that when you look at these shapes, you're going to say, well, which one is the before and which one is the after? So that's why I had you write this down. The dashed line figure will be the image or what happens after, and the solid line figure is the pre-image or the before. It starts off with the pre-image, and then it ends with the image or the after. Solid before, dashed is after. Okay? And you have to decide whether it got bigger or smaller, which is the easiest part. And then the part that a lot of students get confused is the scale factor. How do I find it? How is it used? Well, it can be used in several different ways. The scale factor is this side compared to this side, or this side compared to this side, or this side compared to this side, or even the distance from the center to the image divided by the distance from the center to any vertex. The scale factor gets multiplied by everything. This side, this side, this side, this side, this side. It's the same number every single time. Otherwise, it would distort it. Otherwise, it would not be in proportion or not be similar. So if I ask you to find the scale factor, basically, it's image divided by pre-image. If you remember image, let me just crash my computer real quick. Oh, successful. Okay. Let me just restart my computer program again. If you do image divided by pre-image, you are going to be just fine in figuring out the scale factor. How do I tell which one the image is? If it's dashed in this worksheet, or if it has the apostrophes. If it has those little apostrophes, that will let you know which one the image is. So let's do some examples together. I have picked 1, 3, 6, 9, and 10. We have 5 examples that I can do with you. Number 1. The dashed line figure is the dilation of the solid line figure. The labeled point is the center of the dilation. Tell whether the dilation is an enlargement or a reduction. So, this is what happened after. This is what happened before. Is it an enlargement or a reduction? If you know, say it out loud. There are a lot of incorrect people. I heard a lot of wrong answers. This is after. This is after. This is before. It went from bigger to something smaller. This is a reduction because it got smaller. So how do we then find the scale factor? You take the image, and it doesn't matter which one you pick. You pick a side and the other side. The image divided by the pre-image is what we're going to use. The image was 1 inch divided by 2 inches. And guess what the scale factor is? As a fraction, it's 1/2. As a colon, it's 1 to 2, or you can even write out 1 to 2. So that's why I write usually as a fraction. What does that mean? That means that this image is 1/2 of the size of the original. I would accept any of these three answers. Let's try number 3. And number 3 I picked specifically because number 3, they're going to try to trick you with this one. First and foremost, here is the image. Here is the pre-image. Is it an enlargement or is it a reduction? Go ahead. If you think you know, say it out loud. Oh, a lot better. We got a lot better on that one. I did not hear any wrong answers. That's a good thing. Now, the scale factor is where they're going to try to trick you. And the reason why they're trying to trick you is because they're giving you lengths and pieces. They're giving you this side is 3, and they're saying this distance from here to here is 6. But 6 is not the full distance. So what you're going to have to do is you're going to have to use your knowledge about pieces, that this piece plus this piece, otherwise known as the segment addition postulate, makes the full distance 9 units. So if I'm looking at the image divided by the pre-image, and I'm using the right side and the right side image's distance is 9 units, and the pre-image is 3 units. Always give your answer in lowest terms. Reduce this. Some people will want to write it as 3 to 1. Some people will just write it as 3. It's a scale factor of 3. Either way is correct. I don't think I've seen too many math teachers get into too much of a big deal about it being 3 to 1 or just 3. Or 3 over 1. But 3 over 1 is 3, so either way. This is 3 times bigger than that. But they try to trick you because they give you the distance in pieces. Keep that in mind. The next example I have for you is number 6. Number 6, this is where you may want to use a ruler. It's up to you. They actually even give you a YouTube video, but I'm going to show you exactly what the YouTube video looked like by doing this with you. Feel free to follow along. First and foremost, they give you 3 points and they give you a center. Because our biggest or smallest number is -12, I'm just going to write out -1, -2. I'm going to go by -4, -6, -8. I'm skipping some lines just so I kind of have an idea of where my numbers are. And I have a bunch of other negative numbers, so I'm going to do that downward as well. -2, -4, -6, -8, -10, -12. That will help me just as I'm plotting some points. And then what I'm going to do is I'm going to find where A is, where B is, where C is on my graph, and then I'm going to label them. So I'm going to go -10, -8. -10, -8 is right here. I'm going to call that A. I'm going to go to -10, -5, and I'm going to call that B. I'm going to go to -7, -8, and I'm going to call that C. And then I'm going to go find P. P is at -12, -10. And then for me, I'm going to use a ruler. My ruler is this line tool. Bam. Give you 2 more of those. Bam. Last one. And so we have this shape. It's a triangle. You have your A, your B, your C. All 3 points are plotted, and your center point, P, is outside of the shape. As a matter of fact, everything in 6.4 is going to have that center point outside of the shape, which will create, or like you can think of it like a projector. It's projecting something that gets bigger. What this says is that we're going to dilate triangle ABC by a factor of 4. That means it's going to be 4 times bigger. So how you're going to do that is very simple. Here's what we're going to do. We are going to count horizontally and vertically and then multiply that by 4 and do it 4 times. Here we go. From the center point 2A, I go 2 to the right and 2 up. That's how I get from P to A. I need to do that 4 times. So 2 to the right, 2 up. I go 2 to the right, 2 up, 2 to the right, 2 up, 2 to the right, 2 up. Let me just see. I'm going to put a little dot right there, and I'm going to put an A prime right there. I took the distance 2 to the right and up 2, and I had to do that 3 additional times so that it's 4 times bigger than what it was. A scale factor of 1 would put it right back in its same spot. But 4 times we go 1, 2, 3, 4 of those. And that's where we got A prime. How are we going to get to C? Let's go 2, 3, 4, 5 to the right and 2 up. I have to do that 4 times. 1, 2, 3, 4, 5 to the right and 2 up. 1, 2, 3, 4, 5 to the right and 2 up. 1, 2, 3, 4, 5 to the right and 2 up. C prime is going to be up here. And the last point is B. From the center point, I go 2 to the right and up 1, 2, 3, 4, 5. So I'm going to do that 4 different times. I've already gone once. 2 to the right, 1, 2, 3, 4, 5. And 2 to the right, 1, 2, 3, 4, 5. And one more time. 2 to the right, 1, 2, 3, 4, 5. This is where my new B prime is. I'm going to switch over to blue, and then I'm going to connect my dots from B prime to A prime, from B prime to C, and from A prime to C prime. And what I'm hoping you see is I'm hoping you see something that's a triangle and another triangle that got bigger. It got bigger 4 times. As a matter of fact, if you count the side right here and it's 1, 2, 3, well, guess what this side is 4 times bigger than that. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Same thing with the bottom. The bottom's 12. This diagonal got 4 times bigger. Matter of fact, just like that example that we drew, I could see how this just kind of expanded in the same direction, in every single direction. 4 times bigger. You're going to get to do that multiple times on this worksheet. So let's do one last example, number 9. I'll do that with you. It will also lead us into the hardest question, which is number 10. We'll do that together, and then we'll be done with these notes. So we're going to do the same thing for number 9. I see some numbers. I'm going to need to label my axes. I'm going to go -2, -4, -6, -8, -10, -12. These look like positives, so I'm going to just do 1, 2, 3, 4, 5, 6. I think that will be pretty darn close. Going to plot A at -11.3, -11.3, there's A. -11.6 is B. -6.6. And D is at -6.3. makes this rectangle. We got to have a center point at negative 13, 3. When you're done graphing those 4 points and point P, you can connect your dots and make that rectangle. But then it says we're going to dilate the rectangle by a scale factor of 3. It needs to be 3 times bigger from point P. So just like you did before, we're going to do the exact same thing as what we did before, except we're going to be multiplying or doing things 3 times. Here we go. From point P to A is 1, 2. I need 3 of those. So 1, 2, 1, 2, 1, 2. A prime is now at this point, and I'm going to label it A prime, image. A double once, a double twice, a double 3 times. That's going to be 3 times bigger. I'm going to do the same thing for D. 1, 2, 3, 4, 5, 6, 7 units away from P. I need that 3 times. 7. 1, 2, 3, 4, 5, 6, 7. That's 2. 1, 2, 3, 4, 5, 6, 7. That is 3. D prime is now here. For B, I went to the right 2 and up 3. So I'm going to do that 3 times. To the right 2, up 3. That's the second time. To the right 2, up 3. That's the third time. This new spot is B prime. And the last one is C. To the right 7 and up 3 is where C is. I need to do that 2 more times. To the right 1, 2, 3, 4, 5, 6, 7 and up 2. To the right 1, 2, 3, 4, 5, 6, 7 and up. Oh, I'm sorry. It's supposed to be up 3. Up 3. So from here 1, 2, 3. I didn't count that right. And I knew I didn't count right because I knew this had to be up there and equal with that. So let me connect those dots and see if this looks like a rectangle that is 3 times bigger than what it was before. I'm hoping you can tell. That rectangle was an enlargement. It was multiplied by 3. It is the same units away. It's 3 times farther away than it was from the original. Which is now going to bring us into the hardest question, which is right down here. But we're not going to be able to answer this hard question until we answer parts of number 10. So let's do number 10 together as well. Find the perimeter and the area of the rectangle from problem 9. So what's going to help us is if I start counting. This side is 3 units. 1, 2, 3, 4, 5. Bless you. 5 units, 3 units, 5 units. That's going to help me. I'm going to count up 1, 2, 3, 4, 5, 6, 7, 8, 9. This side is 9 units. This side is going to be 15, if my memory serves me correct. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 units. 15 down here, 9 over here. What is the perimeter of A, B, C, D? A, B, C, D. 3 plus 5 plus 3 plus 5 is 16. 8 plus 8 is 16. But the area, that's what they're going to ask us next. The area is not done by adding up the 4 sides. It is done by multiplying how many squares are there. 3 times 5 is 15. Then they want us to do the same thing except for the image. The perimeter of the image is 9 plus 15 That's 24 plus 9 plus 15. 24 and 24 make 48. The area, on the other hand, is going to be 9 squares times 15 squares. I don't know what that is off the top of my head, so I'm going to use a calculator. I got 135 as well. They asked us what the scale factor was. We already know that we had a scale factor of 3. What is the scale factor of A, B, C, D? But they ask us for this first and that second, so we have to do 1 to 3 in that regards. Because they said to put A, B, C, D first and this second, that's what we have to put. What is the ratio of the perimeters? What is the ratio of the perimeters? 16 to 48. 16 to 48. Does that reduce? Let me use my calculator to figure that out. 16 to 48 is the same answer. 1 to 3. The scale factors ratio and the perimeters ratio is going to be the same thing. What's the ratio of the areas? This compared to this, 15 to 135, but that reduces. 15 divided by 135 is 1 to 9. What this is supposed to highlight, what this is supposed to let you know, is that the scale factor increases the perimeter by the same amount, but not the areas. The areas actually take that scale factor and you square it and you square it, and that's the ratio of the areas. Kind of hard to see just off of one example. So then they ask you an even harder question. If the ratio of the two similar figures is A to B, then the ratio of any length is going to be A to B. Think of it as 1 to 2, 2 to 4, 3 to 5. It doesn't matter. It's A to B. The ratio of the perimeter is not going to change. It's going to be the same. A to B. But the ratio of the areas will change. What do we do to go from the 3 to the 9? We squared it. What do we do to go from the 1 to the 1? We squared that as well. It's going to be A squared to B squared. And that's where we're going to end your notes for today.